So today is Mobile Monday and we're able to fit in a radio. Today it's a Eurosonic ES407, which looks remarkably like a Moonraker Minor from about 1999 era. And interestingly, it has a price tag on the back of £63.50, and on the back of it, it has one of our stickers, which Mark went through these when they would have come in, and he says it doesn't work at all. So that's where it stands. It still has its fuse holder, even though the lead's a bit chewed up. So, I'll get rid of that screw, and then I'll open it up and we'll take it from there. Okay, so the first snag we've got is I can't find any information on these, so I'm not going to waste time. I'll just get on with it and wire it. So what I've done is to put the pins in so that I can meter easily, and the second thing I've done is to get the meter out, put it on continuity, and see which pin is ground. So the first pin, well, all I need to do is to put it onto chassis, don't I? And pin 1 is ground. So that's our basis. We know pin 1's ground, so I can write that down on the list, and all I need to do is to short out between ground and something, and it will go into transmit. I can't make this have any harm. I'll just plug a speaker into it, and then we'll hopefully hear if I manage to hit the receive pin. So I'll just get a crocodile clip lead. So I'm not gonna clip it to the I'll just clip it to the chassis, it's easier. So we know one's earth. I better switch the radio on, that will help. So pin 2, they are not labelled how I'm telling you. It's because pin 2's in the middle. I can't remember which way. I'll just have to look at a sheet. Yeah. So from this side, pin 1, pin 2, pin 3, and I think it fills in with 4 and 5. It does, yes, and 4 and 5. And the reason for that, if you wondered why DIN plugs look a bit weird like that, it was when mono audio was around. You got record and playback for a tape recorder on a 3-pin DIN. Then when stereo came around, the right-hand channel filled up the 4 and 5 because the left-hand channel was the mono channel. So that's why it's a funny way around. So we know that pin 1 is earth. So all we'll now do is we'll go on to the second pin, which is pin 4, and nothing happens. We'll go on to the third pin, which is pin 2, and nothing happens. We'll go on to the fourth pin, which is pin 5, and that just sounded like it went into receive. I'll just turn the volume up. Yeah, very quiet. Is that because the squelch knob is stuck? That's why. And then we'll go on to pin 5. So we can soon determine the audio. So if we short out pin 1 to pin 3, so that's the extreme left to the extreme right, we're now in transmit. All I need to do is to put a test probe with my finger on the next pin. Well, that's clearly it. I'll just I'll check with the monitor receiver. That's a fairer way. So I've got a blank carrier. In fact, I'll unplug the extension speaker because that's just coming through the monitor receiver now. So the second pin along, which is pin 4, is in fact So that's audio. So the trouble is, I'm not getting normal receive. So it's like the squelch is on all the time. So I can't determine which is the receive pin. I guess it's going to be the fourth one along. So I'm going to wire a mic and assume that pin 3 is connected to nothing and that pin 4 is receive. This is guesswork. But we are sure of 3 of the 4 connections. So we can actually transmit on the thing. Worry about receive later. There's clearly a problem. So you can see that in another region there would be a modulation transformer for AM and other components for AM not used on this board. So it's an AM FM chassis inherently, but not used like that. So I'll switch it back on, and I'm gonna have to deal with the channel buttons because they don't both work. So they're gonna want some cleaning. I want channel 20, which is there. If I can get it down to go down to there, and then it jumps to. Okay, so it's straight away I've got full scale deflection. So we'll just go over to the camera and then you can see what I'm looking at. So the first coil, that's going to be the VCO. We're not going to need to touch that. But the first coil here is L5. I didn't see that first time round. Or is it L3? Oh, I think it's L5. I'll change that. We'll say that's VCO. Can't see the number on the other. So we're going to transmit. It's doing 3.4 watts. And then we'll go for the coil just there. So I'll go through those backwards and forwards until I can get no more improvement. Okay, so that's now got us 4 watts exactly, and that's the maximum we can manage. I'll just try that once more. There we go, 4 watts. Can't be bad. So that's a good start. Now, are we on frequency? No. So I'll put camera 3 on so that we can see that together. So as you can see, it's 2779089. It should be 125. So it's dropped quite a way. Let's see if we can pull that up. I didn't think it was going to go. There we go. Now, one of the concerns I have, if I think about receive for a moment, is that the audio output device there isn't bolted to the chassis, yet it's got heatsink compound as if it should, and a hole through as if it should. Now, this radio is low audio as if the mic's not plugged in, and of course I haven't even wired that, or I've guessed wired it, shall I say, because there is a problem. So someone has probably changed that IC. Yes, it looks like it's been changed, but to no avail. But I highly doubt that it's the audio IC causing it to behave in the way it is doing. Let's do the deviation. So because it doesn't have a meter on the front, it makes the mystery controls at the left really easy to find. So there we are. Let's have a look. I'll just go back to the other camera. Voila. So it's quite low transmitted audio. So let's go for that one. I'm right, it's that one. So take that to about 2 and then give it the whistle test. Voila. It's spot on, 2.2 to 2.5. That'll do nicely. So we know that TX, TX, TX. We didn't know the coil numbers because sometimes the components are written underneath the components themselves, so then you can't see where they are. So we know we've got that sorted, and we know that that is deviation. So chances are that's going to be squelch. Now let's go over to receive. I'll plug the extension speaker in. And we have very, very quiet audio. I'm going to put an S9 signal on, just in case the detector is ridiculously stupidly out. I will just check. It's so low. I can hardly see it on the oscilloscope. I've got some very big sensitivity on there. Well, that brought it up a bit, but that won't be the reason it's wrong. So I will just have a look at that, and then I'll tell you what the outcome was if I can fix it. So what I've been able to determine, if we sort out the squelch preset, I can get normal audio. So I'll have to look into that after I've tuned it. We'll just get on with the tuning at this stage. So we'll put the cyanide meter on. We've still got the squelch coming in. Better. So that's 3 microvolts, which is... I'll just move the camera over to the cyanide meter. So it's already receiving fine, but we'll just go through everything. So it's going to be L1, 2, 3 and whatever that's called. L1, two, L3, and whatever that one's called is the receive end. And we've got an IF on here. and then I'll recheck that detector one, which I kind of did roughly, and I'll put the camera onto the oscilloscope so we can see the maximum peak on that. I'll just turn that light off so we can see it better. I'll just adjust that back somewhere normal, and we'll make sure that that's now peaked. I'll turn the volume up and the sensitivity down. I think that's about it. So sensitivity is pretty good. So I'll go back to cyanide meter, and I'll tell you what the sensitivity is. So for 20 decibel cyanide, it's 1 microvolt, which is very good. Let's look at some more meaningful ones. For 12 decibel cyanide, let's get that spot on. It's 0.6 of a microvolt. And for 10 decibel cyanide, it's about 0.53 of a microvolt. So let's see how we can hear it down to. So that's 0.3. That's me knocking the thing on frequency. So that's 0.3, 0.25, 0.2, 0.15. That's about where we can hear it down to. So that's fine. So I'm going to bolt that chip as to how it should be, and we'll see if we can find why the squelch isn't working. It's one of these sets I don't seem to have a circuit for, so it's a bit of educated guesswork. And the squelch could be faulty. It could be the transistor there, it could be the chip there, or anything in between. I think the squelch is faulty. So roll forwards an hour, and I've got back onto this job. And what I've found, we've got another one in stock, just the same. It's got the lids half on, half off, and so the microphone I've made up for the first one, we can plug into the second, and it starts receiving once the mic's on. So I know that the mic is wired right, and so it's an internal fault that's causing the first one to not work. So I can measure some voltages in here to come to a diagnosis on the one we've got here. So that's what I'm going to do next. And without having to do that, here's the squelch control connections. Simply shorting them out, and the squelch works. So I think we've got a simple situation of a faulty squelch control. So the reason I've come to that conclusion is if we put the test meter on the first two connections, we've got just under a volt. If I go onto the third connection, that's 0. Perhaps that'll be deck. And look, this is still, it never changes. So it looks to me like the squelch potentiometer is open circuit. Now that's an interesting story, isn't it? Because the big question then is, do we have anything that fits? So I'm going to pause the video and take the radio apart further and remove that control. Okay, so we've changed that, and now we can work the squelch control. So that's all that was wrong with it. It'll have had a bash on the front, and when you dismantle it, you can see here is actually snapped. So we'll set the squelch up. So turn the squelch to a minimum, turn the signal generator off, set the squelch to threshold, switch the signal generator back on. 1 microvolt, and it's coming at 3, which is not good enough. It needs to be more sensitive than that. So we'll turn down the preset. My glasses on the floor. It's RV1. We think. Yes, it is. Let's turn it down to there. Switch the signal generator off and set threshold. Switch the signal generator back on. Advance the attenuator. 1, 3. That might have to do. So we'll go to the full extent of the travel. 5, 10, 50, 100 microvolts. That is spot on. Just see whether we can just go back. That there was a little bit more. Just see if we can do better. It's still not quite on maximum. So we'll do the test again. Set threshold. Switch signal generator on. No, it's not having it at 0.3. Let's see when it comes on at the top end. It's coming in at exactly 100 microvolts where I want it. So we'll just look at that lower end and we'll just get a reading for you. It's 3. So it's best you can get is 1.2 microvolts for it to shut and 1.7 to open. So it's not as sensitive as it is ideal, but that's a lot better than some of the sets we've seen recently. So that's it. We are set up and the radio's got good sensitivity. It's doing a full 4 watts. It's deviating properly, and we managed to work out the unknown microphone configuration quite easy. So all that needs to happen now is for the lids to come back out of the washing machine or even dishwasher, and we'll come back and just have a quick flick round. At the same time, I'll do this other one. I've stripped that down, and I noticed that the squelch control's broken in this one too. So it's obviously a common fault. Snaps in half when you drop them. So we'll stop the video for now. Okay, so we have it on the aerial now, and all the parts have come out of the dishwasher, and it looks like a nice radio now. So I'll have a quick flick round. $19.90 on Roger. Okay, so yeah, it's picking 1 or 2 things up. As ever, we don't get a Roger back, but there's just one thing that I would like to have seen. I know it's supposed to be a basic set. I wish it would have had a LED to tell you you're in to transmit. It's the only thing, because you've got no, with there not being a meter, and with no TX light, you've got no reassurance it is actually transmitting. As I key up, I can see my power supply going over to 85 milliamps. No, as I transmit, I can see the power supply going up to 850 milliamps, so I know it is transmitting. So anyway, we'll do an on-the-air test with that later, and there's no reason that I to think that that won't do the full test route. It seems fair enough to me, and somebody paid £63.50 for it. Okay, so thank you for watching the Eurosonic ES407CB, which, although it's on the 2781 format, came out in the 90s. Thank you for watching.